And this is law of sines. Any question? Now let's look at the page 586. And let's look at the problem 8. So we know the one angle alpha, 39.7 degrees. And we know another angle, gamma, 91.6 degrees. And we know one side B. Now, we need to solve this triangle. Okay, so let's go back to the whiteboard. And this is page 586. Problem 8. Alpha is equal to 39.7 degrees. Gamma is equal to 91.6 degrees. And B is equal to 16.4. So when you try to solve a triangle, first you sketch this triangle. Okay, so now let's sketch this triangle. And this is my angle gamma. And then this is my angle alpha. And then this is beta, which is a known. So now B is length of the side opposite beta. So this is B. And B is known, 16.4. So now you know this is the case angle side angle. So it's the case A, S, A, right? So first, we may use the property that the sum of the three angles of a triangle is equal to 180 degrees to find beta, right? The degree measure of beta. So beta is equal to 180 degrees minus the sum of alpha and gamma. So now we have the 180 degrees minus 39.7 degrees and plus 91.6 degrees. And then you simplify, you have the 48.7 degrees. So now we know all those three angles. And we still need to find the length C and A, right? And let's first find the length C. So by the law of sines, we have the C over the sine gamma equal to B over sine beta, right? Then we multiply both sides by sine gamma. We get a C, which is equal to B times sine gamma over sine beta. Now you plug in all those knowns into this expression. You have the 16.4 times sine gamma. Okay, gamma is the 91.6 degrees, and divided by sine beta. Beta is the 48.7 degrees. And then you simplify, you have the approximately equal to 21.82. So this is the length of this side C. Okay, so the side opposite angle gamma. And then similarly, you can find the A. So you start with the A over sine alpha equal to B over sine beta, and then this just implies you multiply both sides by sine alpha. You have the A equal to B times sine alpha over sine beta. And you compare these two equations. You see here, you want to find C, you use angle gamma, right? If you want to find the A, you use angle alpha. So just replace the angle gamma by alpha, then you get the A. Now you plug in everything here. 16.4 sine alpha is equal to 39.7 degrees and over sine beta 48.7 degrees. And then you simplify, and this is approximately equal to 13.94. So now we solve this obtuse triangle. We find the 3 angles and also the 3 sides. Any question? Now let's look at the page 585, problem 2. So in this problem 2, we know 2 angles and also 1 side, and this side is not between these 2 angles. Okay, and we need to solve this triangle. So this page 585, number 2. So let's copy this sketch. Okay. And this is beta equal to 121 degrees. And this is gamma equal to 16 degrees. And then this is the length B, 4.2. So this is angle side, right? This is the type angle side. And fourth, we can find the missing angle alpha. So let's find this angle alpha. So by the property that the sum of the 3 angles of a triangle is equal to 180 degrees, then we know angle alpha is equal to 180 degrees minus the sum of the beta and gamma. So you have the 180 degrees minus 121 degrees plus 16 degrees. And then you have the 47 degrees. So this is the degree measure for the angle alpha. And then you can use the law of sines to find the other 2 lengths, A and C. So as in the problem 8, we have the A equal to B times sine alpha over the sine beta, right? You look at this equation. So in the future, you may just directly use this result. You don't need to start with the law of sines. Yeah, question? Okay, this alpha should be equal to 43 degrees. Okay, I made a mistake here. So alpha equal to 43 degrees. And then we use the formula from the problem 8. So A is equal to B times sine alpha over the sine beta. And then you plug in the knowns into this expression. You have the 4.2 times sine 43 degrees over sine 121 degrees. And then you simplify, You got 3.34. So this is the length of the side opposite angle alpha.